Yeah, got a haircut. Uh, these slides are on the course. These are Friday slides. I just want to go over the Docker Compose slides a little slower. I rushed through them last time. And this week is all to help you with the project. So there's no unique slides for today. The This week is meant to help you with the project, and one of the big new things is Docker Compose. So I want to make sure everybody's up with that. Yeah, I got a haircut. It's tough to get a haircut these days. So I just gave myself a buzz cut. I said, screw it. I'm sick of the long hair. my wife says it looks dumb, but I don't care at this point. I'm just locked up in my house anyway. Hey, thanks, Noonsum. Yeah, I was thinking of going the other way. I was either going to grow it out or cut it all off. I ended up cutting it all off. But, so since this whole week is meant to help you with your project, not just phase 2, but also phase 3, since now we have authentication, and also homework 8. So homework 8 and the project and any oddball topics that I can think of, and I'll try to stick to the original advanced front end stuff like was on the schedule. Not today, but at least maybe a little bit on Wednesday and Friday. But all those 3 topics, advanced front end stuff, and I used the word advanced pretty lightly here because anything beyond what we've done so far with the front end, I'll call advanced, even though we've done almost nothing with the front end. So anything we do is going to seem advanced. I'll be able to use that label. Anyway, more front end stuff. I'll say more front end stuff. That sounds better. Homework 8 help, project help. So if anybody has questions throughout lecture, I'm just going to, by default, show you whatever I think is going to help you with those things, wherever I think the class might be struggling, things that I don't feel I explain very well, things like that, I'll go over again. So I'll kind of have my default track of things that I want to show you, and I got my windows open here to show you those things. But please stop me if there's something that just doesn't make sense. There's no new content this week that you'll be held accountable for through an assignment. So please guide the lecture to what you need to see, because this week is all about getting everybody caught up. And showing some new front-end stuff with that. So I'm going to continue what I was doing on Friday. I'll go over these Docker Compose slides again, and a bit more slower, and explain it a bit more because I rushed it at the end of lecture last time. So I'll go over these Docker Compose files, and then go through the image sharing app at tictactoe.info. I'll go through this app, the code, the new features that we didn't get to see last time, everything about this site, to give you the idea of how that goes. The image sharing site, the reason I built this is it's very similar to your project. Users can post images, users can vote on images. Obviously, I don't have all the features for the project. I don't want to just give you a completed project because I know what happens when I do that. At least in 1.16, that's just all I see is cut and paste of my code and just a few tweaks, unfortunately. But maybe I wouldn't have that problem in this class, but I'm not going to risk that. But it does have the sharing multimedia. That was one topic that I'm showing you through this app. What to do once a user's logged in. Once you authenticate a user and you have that token and all that stuff set up that we talked about in these slides, what do you do with that to actually treat that as a user and as a user account? Things like that I'm showing you through this app. So let's revisit Docker Compose. Go through this this file again and talk about the parts of this. I'll blow through some of the parts that I think we got pretty good last time, and then those last few slides where I rushed it, definitely spent some time on this. So this is the entire Docker Compose file for my for the image sharing app, and then I also have one Docker file for the app itself. And I want to go through this Docker Compose and figure out and see what we have here. So the first line, the version number of the Docker Compose file, This is whatever version happens to work with the feature set that you're using, what you expect from the file. I believe this goes up to 3.8 possibly. So if you need any of the cutting edge features, you might have to change your version number. And if you're using those features, I would assume that you know what version they're in. If you're using something advanced, I assume you know what to do with that. So I don't really have to spend time with that. If you have at least 3.3 here, you're going to, of course, be able to use any of the features that I'm showing you here. Next, you're listing your services. And by the way, this is a YAML file. This is, I mentioned this very briefly earlier in the semester, probably last week. But a YAML file, YAML is a format similar to JSON. And it's, in its solution, like that, it's trying to solve the same problems as JSON. How do we represent fairly complex structures of information in a text format? And YAML has just different syntax than JavaScript, or sorry, JSON. JSON has braces, and brackets are the big thing of how it's controlling the data. YAML files are formatting this with indentation. It's more like a Python feel. Colons and indentation. So we can have key value stores. The version is a key with a value. Service is a key with a with more key values as its values, so we can represent this information. The services, we have Mongo and app, so 2 services running. One question I've been getting quite a bit lately that I want to try to squash this one as much as I can. It's been on Piazza. Nick's been asking me a few times and kind of forwarding these questions to me, so I hear it a bit, even if I'm not there answering them on Piazza, is you do have to run a database in a Docker container for the project. So this is actually, I'll check right now. This is something I've been getting questions about, and I want to know where the questions are coming from, actually. I think I did. Yeah, I did. List Firebase right here. So you actually can't use Firebase on your project. When I wrote this, I was listing off all the services, a bunch of services and stuff I could think of. And I happened to mention Firebase there, but you can't actually use Firebase for your project. You can't use SQLite for your project because I did add, which when I wrote Firebase there, I wasn't sure I would have this requirement, is you do have to run your database in a Docker container because Docker Compose is a requirement of the project. The reason I wrote Firebase there, I did have this more planned out than I made it sound just there. The reason I had Firebase there is I thought I was going to have Docker Compose with a Docker database image on Homework 8, and I decided to not do that on Homework 8. But now I still want the class getting practice with that. I want you to know what Docker Compose is because this is something that you have a high probability of seeing out there in the wild. Maybe not with a database inside a Docker container, but you'll see Docker Compose running multiple containers to build one app. To have this app, one single app with multiple services, is something you're going to see. And some shops take this to the extreme and do something called a microservice architecture, where you split your app into a lot of different services, have them all running, and have all your parts of your app communicate with each other through those services. So you have smaller, more module pieces to your app instead of having one big, what we call a monolithic app like this, where you have one giant app and then maybe connect to a database. What a lot of teams are doing is chopping teams out there in the wild. I don't mean teams in the class. Is chop up their app into a handful of services. Those services have APIs, and then a separate team working on just one service can just focus on delivering that API, get that functionality for that part of the project, and then the other parts of the team are going to access that API, assuming it's going to work. It's a nice way to have modular code, have separate test suites and everything for your parts of the project. And as long as each part works pretty well, then it's up to the integrating all those parts and testing that as well. Whereas if something goes wrong with a monolithic app, it can be harder to debug. So there are pros and cons to that. There's a big debate out there in the industry right now whether microarchitectures are worth it or not. But that's something you're likely to see. You're going to see a Docker Compose file with multiple services, even if it's not a database. The problem with putting a database in your Docker, in a Docker container, is if something goes wrong with that Docker container, all your data might get wiped out. But there's an easy way to fix that. And you'll see this in the documentation if you read in documentation on how to do this stuff. You'll have another value here for volumes, which is going to map a directory from inside the container and duplicate it outside the container. So then you can back up your database outside of the container. So you can get around that issue. But it was an issue when Docker first came out. It was a pretty big problem. And there's a lot of developers that just remember that being a problem and pretend that it is still a problem, is what I can tell is going on out there. ABC auctions do that. Pretty cool because you can write modular. Yeah, exactly. You can write in any language. So if you have that microarchitecture, each piece can be written in any language. If you're adding a new part to the project, you don't have to say, this is a Node project, so you have to write this in Node. You have to use JavaScript. You just write it whatever architecture you want, whatever language you want. That way, if there are multiple parts of the project where there's a different best choice for language for each part, that you can get the benefits of every language and every framework that's out there. For example, if you have an app with a lot of AI, a lot of machine learning and stuff like that, you're going to want to use Python for the machine learning part because that's just the way AI went. They adapted Python and they've ran with that. So all the libraries are in Python. But if you have something that's got to be very efficient, close to the wire, you really need every ounce of optimization out of it. You're going to want to write that in C. You have that microarchitecture and microservice in C. You get to take advantage of all those things. Or if you make some new, I don't even want to say this one, but if you make some new hires who only know a certain language, but that's a horrible reason. Just tell them to learn a new language. Learning a language isn't that bad. Isn't too tough. Especially, let me rephrase that. If it's for a course and it's one semester, it can feel a bit tough picking up a new language, especially when you have multiple other courses. But when you're on your career and you have years and one real thing to do, picking up a language is nothing. Like that's barely even barely even registers on your workload in the long run, in the grand scheme of things. If you look at the first 5 years of your career, you're going to be like, wow, it took me a month to get familiar with that language. Visual Basic. So with our Docker file, we're going to specify each one of those services, each part of our app running as a separate service, and give them a name. These names are critically important. The names themselves, not too important. It's whatever you choose. I could have named this My Awesome Database, and look at it, I made an app. Those could have been my names. Those are perfectly valid. But being consistent with these names is very important. So this is how we're going to connect these services together. Docker Compose is going to build its own DNS, where these are going to be used as the host names for our containers. So if we want one container communicating with another one, we would use this as the host name. So in my app, I want to connect to this database. And even right here, I'm using this host name. I'm going to use whatever name I gave it here, and Docker Compose is going to see communication from inside a container for this one project, and it's going to say, "Oh, you told me about a container with that name. You must mean that host," and then specify the port as well. So this is going to be used as the host name. So you can also expose ports. So notice that I don't have any ports exposed. I'm using a raw image, not exposing any ports, and I'm not mapping any local ports. You can also do this, and you've seen this, you saw this 2 Fridays ago, whenever the first time I showed this Docker Compose file. You did see me mapping ports. I mapped 27017 to my local 27017. I do recommend that you do that for testing and debugging, because when I don't expose that port to my local machine, so on my actual machine, I can't access this database. I can only access it from another container inside of this Docker Compose file. So I can only access it from inside my app. So that means if I'm testing this, and when I'm testing this, I would have to run Docker Compose, which might take a long time, depending on your setup, depending on what's in your Docker file. I have, for some reason, installing G-Event in Python takes a long time every time, and it doesn't cache properly. So it just took a while. So if you expose a port, expose 27017, go into your app code and change Mongo back to localhost. Then you can just run your app to test it instead of running it inside Docker Compose. So a little setup to make your debugging a lot easier. I can just run my app file and have it access that container instead of running Docker Compose every time I want to test. So just something that speeds up the debug process. You could also download, install, and run MongoDB on your machine itself. That would work as well. You'd have 27017 have to access localhost 27017 to access your local MongoDB, or you can run the container and map that port. I recommend doing the container just because you can get more practice with Docker that way. All right, so we named our services. Now we got to specify how to build each container. For Mongo, is there login to connect to the database? For me, it just connect. So by default, Mongo does not have a password or a username. Like MySQL, if you played with MySQL, you have to specify a username and a password, or use the default root username, the root account, and specify a password, and then provide that password when you log in, that username and password when you log into the database, whenever you connect to it. Mongo, by default, does not have any authentication. You can add it, but it doesn't have any authentication. But also, by default, you can only access MongoDB from the... it doesn't allow network connections. I'll say it that way. It doesn't allow any network connections. I was going to say from localhost, but we're clearly not doing that here. We're accessing it through DNS. But it won't allow any networked connections. By default, you would have to explicitly tell Mongo to be able to take a remote connection. So that's how we get around that. That's how Mongo gets around that security issue. Because if there's no password and everybody knows you're running your database on 27017, there's nothing stopping someone anywhere in the world from connecting to your database, stealing all your data. That'd be a horrible, horrible flaw in your app. Somebody could just steal your data because that's what you're set up to do. You're set up to say, here's my data. So by default, no remote connections and no password. MySQL, on the other hand, by default, allows remote connections but requires a username and password that you set. So if you just set a really weak password in MySQL, if it's 1, 2, 3, 4, 5, 6, like I have in my examples, then everyone in the class, if they want to try to attack you, that's the first thing they're going to try. They're going to say, well, maybe they just used the password from Jesse's slides and steal your data. So a few things to think about there. And they know your host name. They know your app's going to be out there live. Well, I'm going to change your password. It's going live. But if it's teamwhatever.cscsoftware.com, I'll change your database passwords when I deploy, though. So it's a little irrelevant. But if you're out there building an app saying like, hey, look at my project, I did this thing, things to be careful about. But that's one difference between Mongo and MySQL. Just by default, what are their security measures? Can you have more than one wait host? Yeah, I believe it takes a comma-separated list, if I'm not mistaken. But I could be wrong on the formatting. But yeah, I'm quite sure that script does take multiple parameters there. But I'd have to look up the syntax and make sure that it does. If it doesn't, I mean, that's open source. That's just something somebody wrote. Like somebody said, wow, this is an issue when we're waiting on a service that runs on a TCP port. This kind of sucks. And they just wrote something and shared it with everybody. So that code's probably not too complex. You could go in the source code and update it if it doesn't. But I'm pretty sure it takes a comma-separated list. But I might be thinking of something else. So Mongo just runs off an image. If I had a Docker file that just said from Mongo 4.2.5, that would be the exact container that's built here with no extra parameters, nothing extra here. I'm just saying my Mongo service, just take this image and take it as is. Whatever that image is, use it. I could specify more parameters here, and if you're using MySQL, you want to specify your environment variables for your database, your username, your password. You'll specify those right in this service as you're building it. With Mongo, I just need vanilla Mongo. I don't need to set any parameters, so I'm just pulling from that image. My app is going to build from a Docker file. To specify that, I don't specify any image, and I do specify a build. This is going to be the build path, and this is the same, and I'm saying use the current directory. This is the same thing as the trailing dot when you build a Docker image. When you say Docker build -t Docker name, image name, and then that dot at the end, that dot is saying look for a Docker file in this directory, in the directory that I'm currently in. So I'm going to put my Docker Compose file and my Docker file for my app in the same directory. Go to that directory when I run Docker Compose, and then Docker Compose is going to look in that same directory for a Docker file and then build from that Docker file. So if I had multiple services, I would put each service in a different directory, and for each service, I would put the build path as whatever directory I use for that service, for that microservice, if I'm using that architecture. Next, setting environment variables. This is the part you would need to do with MySQL. If you have a MySQL container, set your environment variables with your passwords and database and stuff. Here I'm using it for this wait hosts. We talked about this. This is the third time I've shown this in lecture, so hopefully this is out there. But the big problem we have, I better not hear about this problem in office hours or Piazza. We've talked about it a bit, but there's a big problem here, is that if Docker Compose is going to spin up both of these containers and just build them, run them, and run whatever we have for the command, MongoDB is going to run its startup script, and my app is going to run app.py, I think, for this one. It's just going to, oh, it's right here. Yeah, Python app.py. App.py, the first thing I do in that file, one of the first things I should say, is connect to the database. I look for Mongo port 27017, and I go to this container and say, hey, I'm trying to connect to you. Let's make a connection so I can start sending you queries. Well, in all likelihood, in pretty much every case, by the time my app gets to that line where I'm connecting to the database, this container, this database, is still running its startup script, and it's not ready to accept a TCP connection yet. So my app errors, crashes, and then a while later, Mongo's done with its startup script, and it says, hey, I'm ready for connections. Let's be an app. Let's do some cool stuff together. But my app already crashed at that point. This is the problem we have to avoid. Docker Compose does not have any method to wait for that database to be running. Docker Compose does have a mechanism to wait for this container to be built and to be running, but Docker Compose does not know that once that container is completely up and running, that it's still running a lengthy startup script. That's our issue. So we can use a wait variable and have it wait for this container to be built and running, but it's only waiting for it to be running. Running means it just called its startup script. Doesn't mean that startup script finished. That's our issue. So for this, we're setting an environment variable, wait hosts, telling it to wait for a specific service and port combination. And then we're downloading this thing, this UFO Scout, built and shared with the world. We're downloading their command, their wait command. We're making it executable so we can run it. And then we're calling the wait command before we're running our app. So we call this wait command. This wait command in this code is going to look for a wait host's environment variable. It's going to read that variable, and then it's going to wait, as the name implies, wait until this port is accepting TCP connections. Once that port's accepting TCP connections, at which point we can confidently say our startup script is ready, then this is going to return, and then we can start up our app. So this is a workaround. There are other workarounds if you want to play around with what else is out there. But this is the one that I felt, at least out of the ones that I looked at and used, this is the one I feel was the simplest. It's the easiest one to get up and running, and the most kind of compact way to do this. So that's the one I like. That's the one you can use. That's the one I recommend. And actually, while we're on this, since I did mention it, this guy, Francesco, that's fun to say. Yeah, so it does take a comma-separated list. And we can take a look at what this thing is. If I can find it. Docker compose, wait, release, download. Guess we do gotta go into sources. All right, I did this last time during Q&A. I went down a rabbit hole. I'm gonna call that one, I'm gonna stop that one before I go down another rabbit hole. And then exposing a port, this is the same as publish 8080 800 when we're running a Docker container. So all those command line parameters that we used when we were running just plain Docker, we still have to specify that same information, but we do it inside our Docker compose file so that the directory we're building from, exposing the ports, those we're still going to specify, and then detach, we're going to specify that when we actually call Docker compose to run the app. And with these service names, whenever we need a host name, and specifically whenever we were using localhost, so when you're connecting to a database, this you would just use an empty argument list, and it would default to localhost. Whenever you would do localhost or 0.0.0.0, whenever you're using something like that, you're going to replace that by the service name that you used in your Docker compose file. So now instead of connecting to localhost, we're connecting to the container named Mongo. This only works if you're inside this Docker compose file. So this code is inside this app, inside that app.py. This is inside this container. Since they're built with the same Docker compose file, they can communicate with each other through these host names. So we're going to connect to that host name, which is running that Mongo database. If we're exposing the port 27017 for your testing, if you're testing your app just by running Python app.py in my case, you would change this back to localhost, expose port 27017, run this container, and then connect to that locally mapped. Then connect to that locally mapped port name. Yeah, it was in here. I guess I'll go down the rabbit hole a little bit here. Coffee and burgers, just 917. Wait. Oh yeah, look at that. And timeout. Oh, I know what I wanted to see actually. You know what I do want to see in this code? This right here. This is where it's going to be. Oh, come on. Make me look like a fool. None of that. None of that. Just want to know where it reads the environment variable, where it actually says read the wait host environment variable and wait config from environment. But where's that? Where did that come from? Oh, there it is. And we can looks like we can specify the timeouts and have some functionality here. But here's where it's reading that wait host environment variable. All right, let's. I was hoping to look at quite a bit of code today. I guess since we have all week, I'm not going to sweat it too much, but we'll try to get to some of it today. So our host names, I mentioned all that, and let's get to this app. So let's talk about this app. This is the stuff. I didn't mean to take 34 minutes on stuff we already saw, but hopefully we're squashing all the Docker Compose questions, or at least most of them. And maybe I should give another example of MySQL to squash those ones. But you do have to use Docker Compose to run that database and your app, and then connect to that database using Docker Compose. I want everybody to get their hands on that. And actually, now I'm thinking about it more, maybe that should have remained in a homework, just to make sure that everybody gets practice with that. And one of the things I'm considering for next time, the next offering, is having every homework, or at least maybe except the first couple, but have every homework require a Docker file, and have everybody just get a ton of practice with Docker, since it is pretty ubiquitous these days. All right, so let's take a look at the app. Here's that Docker file we've just been staring at for a while. It's the entry point to build this app. The Docker file, we haven't seen this in actually it was just on a slide, but we haven't talked about all the lines of this in a little bit. But you're used to these. You've done this for phase 1 of the project. I like to change into the home directory, give that some name, copy all my files over, install all my requirements, expose port 8000 so I can map 8080 to 8000, and do our little patch here from UFO Scout, and then run the app. The app itself going to be a Flask app connecting to that Mongo database. And when I'm connecting to the database, here's that line we saw where I'm specifying Mongo instead of localhost. So I'm connecting to that Mongo container, that Mongo service from Docker Compose. I'm going to connect to that, then get my database, get my collection out of that database, and then I can start working with that collection to be able to interact with my database. So this collection is going to store all of the images that we share. And we saw the storing of images already. We saw the... Oh, that's voting. We saw the image stuff, so let me just quickly go through this. An image upload, I'm going to give a random image name, and I do have a small chance of collisions here. But for our purposes here, I'm fine with that. For a production app, something I'm going to deploy and use, this part would have to be modified to make sure we don't have any collisions. We don't want two files getting the same randomly generated name. So that's something I would have to fix. The quick and dirty way to do that is to generate a random image name, go to the database and say, does this name exist? If it does, give me a new random role and see if that one exists. It's kind of hacky, but that's one way you could do it. Or you could get a more sophisticated approach and generate unique tokens like that. Give me an image name, and this is something you'll have to do for phase 2, is when you're uploading this multimedia content, I want to save the content and also store in my database a link to that content or a reference to that content. So I'm saving I'm saving that image in an uploads directory, and which I don't have here. I haven't ran it from, actually, let me, I have to go into the Docker container to check this. So let's enter in the container. This is something I wanted to show anyway. I was just going to do it for the database, but I get to do it a little early here. So I'm going to enter into this container and run bash so I can get my command line from inside the container. And I use the container ID to do that. This docker exec-it container name, and then the command you want to run. I want to enter in my bash shell, so I'm going to use bash. All my directories are right in the root because I changed that environment variable for my home directory. And if I check out the directory name, it is /root because I created a directory named /root, made that my home directory. So everything's going to be right there, and when I enter in this container, I'm right in that home directory. I can see all my files here. I'm going to have, oh, you know, because I wasn't in the public directory. Public uploads, and we can see this is where the images are being stored. Whenever you upload an image, it's going to show up right here. So if somebody uploads an image right now, if they did it in between LSs, there would be another image there with that random file name that we're generating. So that's, this code here is saving that image to a file, and then storing in my database a document with that file name, so I know how to find this image again, the total number of votes that it has. And here's the new part that we haven't seen yet, is I'm going to track which users upvoted and which users downvoted this image. So I want to know who's upvoting and who's downvoting, mostly so I can check if somebody does vote for this image. I don't want them to be able to vote. I don't want them to be able to vote twice. I lost one of my windows here. So if I log in here and I try to vote this image, I get my message, I can't vote, and I can't spam the vote button. Like the first time we saw this app, you could just spam it, and I even executed a command to just continuously vote. I can't do that anymore. I can change my vote to a downvote, but then it's going to say you already downvoted if I try to do that again. Switch it back to an upvote and get those messages. I already upvoted these ones, so I don't get to vote again. So we can get that functionality there. So that's what we want. So I'm going to store the upvotes and downvotes, and with authentication we can get something like this. And then store that record, that document in the database, and then let every user know via WebSockets that this new image exists. We're going to broadcast to everybody, hey, there's a new image, check it out. And so we could we could store the image in the database, but that's generally bad practice to do that. These databases are not quite optimized to store just large blobs of binary, which in SQL is actually called a blob, a binary L object. What's that? Binary large binary object, but they flip the characters. That's what it was, right? So you could have those in the database. You can do that, but it's not recommended. I recommend doing it this way, and I think this is the generally accepted, pretty widely accepted best practice, is to store your images in your file system and then only store references to those files, the file names, in your database. But you could, if I converted this to base, if I base 64 encoded this, I could store that as a string in my database. Mongo probably has a way to store bytes. I just don't know it off the top of my head, but I wanted to just store the bytes in there. SQL does have a way to store bytes. You could store those bytes as a blob. So you can do that, and if you do that for your project, I ain't gonna judge. But I think this is universally the best practice, is to store your binary information, your big static binary files, outside of the database. Tell everybody we did that, and then I'm just going to return a success message when which doesn't show up on the site anywhere. It does print it to the console, but I'm really not doing anything with those messages. I want to jump to... You know what? I know what happened. I didn't even copy my public directory here. That's what we're looking at. So, my index, let's look at it. We'll have to look at it in here. Let's clear. So my index.html, there's not a whole lot here. I'm importing my JavaScript is the big thing that we're doing. I'm using socket.io for my socket library. Calling my initialize to set everything up. Having the form to submit an image, this form here. And then an empty div for my images and an empty div for any feedback that I'm getting. So this feedback is in this empty div, which is just an h1. Sorry, not even a div, just an h1. And then all these images, all of this down here is this empty div that we're populating. And we're doing that through these commands, not on screen yet, but control. Oh yeah, I put them in controller. So when you first visit the page, we're going to call load images. That's going to make an AJAX call to get images, which gets all of the records, all the documents out of the database, and sends the votes, only the votes and the image name, to every user. We don't want to share with everybody whose who's been voting, how they've been voting, and we don't need the IDs. So just the image names and the votes. Send that to all users as a JSON object. So we get all of that information, and we call this render image with for each of those. Render image. This is what's going to go to that images div and add. I'm going to write some custom built HTML for that image. Now here's where something kind of fancy, tricky, I don't know what the word is for it, but something happens here that that gives this app some cool functionality, I guess. I don't know. Let me just explain it. I'm going to add this HTML to the inner HTML of that div that's initially empty. I'm going to append to it this image with that upload, that file name as the source. So we're going to use this when we get the callbacks from this Ajax call. We're also going to call this whenever we get socket on new image, render image. Directly calls it. So whenever we get that new image that I said when somebody uploads an image, that last thing we did was emit that to everybody. We're going to broadcast that, hey everybody, there's a new image. We're going to call render image there as well. We're going to append to the end of that HTML this the image itself with that file name as the source and appending our uploads directory to it. And the buttons where upvote and downvote are going to have the name of that image passed to it. So my upvote and downvote buttons are going to take the image name as an argument. So when I build this HTML, I get these buttons, which will be the upvote and downvote buttons for this particular image. And they will be linked to that through the onClick by appending that information there and display the number of votes. Now, when this image tag, this image element is added to the DOM, there's immediately, my browser is going to look at that and immediately make a request for this new image. And this is the cool part I was mentioning. That you might think that you have to trigger that call somehow, that something has to happen. But no, once you add this to the DOM, the browser is going to say, "Oh, we need your source image. We need this image," and then it's going to make another request to your server with that information. So we're getting the image name. We're adding that to our image element. That's going to make a request for that image, and then we're adding the upvote and downvote buttons for that image. And the number of votes is initially 0, so we're not passing a votes argument for this. This is a brand new image. In that case, votes is already 0. If it's something that we got from the Ajax call when we first visit the page to populate all the images that have already been uploaded, in that case, we're going to get the votes, and we'll have those votes there. When we upvote or downvote, we're going to send over our WebSocket that upvote or downvote in this format, the image name, and is it an upvote or downvote. When we get that vote, that's when we hit this big block of logic, which for the sake of time, I won't go over in detail right now. Maybe we can save that for Wednesday. I really thought we'd get through a lot more of this today, but that's fine. We have content for Wednesday. We have a good starting point. But this is the logic that's going to say, have you upvoted or not? We're going to get the upvotes and downvotes for this image. And if my code, looking at it now, it's a little bit of a mess. But if this is an upvote and you are not in the upvote list, you haven't upvoted already, then register this as an upvote. If you have already voted, not in, oh, that's part of my, yeah, so if this is a valid vote, whether it's an upvote and you haven't upvoted yet, or it's a downvote and you haven't downvoted yet. Then it's a valid vote, and if it's an upvote, add this user to the upvotes. If they've downvoted, remove them from the downvotes, and vice versa. If it's a downvote, add them to the remove them from upvotes and add them to downvotes. Compute the total number of votes and update the database. Update all documents with this image name and give it the new votes, upvotes, and downvotes lists. And then emit to everybody, say, hey, there was, and I'm doing that by using the socket server itself, the whole server. Emit to everybody that there's been a new vote, there's an update in the votes, and then send them that image name and vote so they can all update their pages. And if it's not a valid vote, if you've already voted, emit without the socket server, so emit just to the sender that they've either voted for this, upvoted, or downvoted for it already. Or if somehow they got to this page, which isn't too hard to do, if they got to this page not logged in. I don't block the content itself, but once they try to make an action that requires auth, I tell them they have to be logged in. Actually, can I? I don't know if I can get to that.